All right. In math, unlike in politics, truth is defined.
How so?
All right. So let's say we're given an if-then statement. If something, then something else. The only way for the statement to be false is if the hypothesis is true and the conclusion is false.
Hypo what? I'm confused. What are a hypothesis and a conclusion of a statement?
All right, let me explain using an example. Your parents give you the following statement. If you pass your geometry test, then I'll buy you an ice cream. So the hypothesis of this statement is you passing your geometry test. That's the first part. And the conclusion of the statement is buying you ice cream. So by the definition of true, the only way for your parents to lie is if you pass the test and they don't buy you ice cream.
What if I fail the test, but they still buy me ice cream? Does that make my parents liars?
No, silly pants. Your parents only told you what was going to happen if you passed the test. If you didn't pass the test, if you failed, anything they do is honest.
So if I fail the test, it doesn't matter if I get ice cream. My parents still told the truth?
Yep. In math, we call this a vacuously true statement. They only told you what was going to happen if you passed the test. So if you didn't pass the test, they didn't tell you what was going to happen if you didn't pass the test.
Coolio. So the only way for a statement to be false is that the first part is true and then the second part is false.
Correct. Let's do one more casual example. If you ride a bus to school, then you will be on time.
Well, I rode the bus today and I was on time, so this statement must be true.
And what would need to happen in order for it to be false?
Well, I guess if I rode the bus, the first part would be true, but it was late. So then the first part would be true, but the second part would be false. This would make the whole statement false.
That's correct.
Yep. Oh.
Now let's go over a geometry statement. Tell me if this statement is true. If two vertical angles are formed by the intersecting of lines, then these two angles are congruent.
Well, let me draw a picture. Okay, I remember that vertical angles are congruent. So we draw a picture. There's my vertical angle. So this statement's true.
Yes, it is. What about if I change the statement a little bit? If two vertical angles are formed by the intersecting of lines, then these two angles are complementary.
Well, let me draw a picture again. Let's see. I guess I could say that's 45 degrees, 45 degrees. So that would be true.
Okay, so you've proven that it could be true. But if you look back at your original picture of vertical angles, this looks to be about 100 degrees. And this looks to be about 100 degrees. So it's true in some cases, but in other cases, vertical angles aren't complementary because 100 plus 100 doesn't make 90. So they're not complementary. So what this is a counterexample. A counterexample is a statement used to prove an if-then statement false by assuming the first part is true, like assuming that they're vertical angles, and finding one way for the second part to be false.
So if the statement is sometimes true and sometimes false, it's considered false in math.
Yes, the same is true in life. If I told my children that I loved them some of the time, do I really love them?
I guess not.
Yeah, so let's see if you can come up with a counterexample to this conditional statement. If two angles are supplementary, then they form a linear pair.
Well, we know that, let's see. Let me think for a minute. I'm going to draw. So if I have a linear pair, that means that they share a side.
Mhm.
But wait, I'm thinking, oh, we could have two angles, for instance, one here that is 95 degrees and another angle, and that would make it, I'm having to do the math in my head, whatever the other measurement is. So these
85.
are not adjacent, right? So they would still be supplementary.
Yeah, so in this example, oops, sorry.
That would have to be 85. Okay.
Oh, I just lost track of where I was. Yeah, so those two angles do add up to 180 degrees, but they're not a linear pair. That's a good counter example that supplementary angles don't have to be linear pairs.
Okay.
Let's come up with one final example. Let's see if you can come up with a counterexample to this statement. If two parallel lines are crossed by a transversal, then the alternate interior angles are congruent.
Let me draw that. So parallel lines and a transversal. I think this is true because no matter what, if I do it, it's still going to be true, right?
Yeah, no matter how we draw our transversal, our alternate interior angles are still going to be congruent. This is the alternate interior angles theorem.
Oh, okay. That makes sense.